In this lesson, we're going to look at the normal distribution. We're going to look at the shape and characteristics of a normal distribution. We're going to look at how to find probabilities using normal tables, and then we're going to work backwards, in other words, finding values if we're given a probability. In the real world, many things follow a normal distribution, things like heights, weights, IQs, etc. Now, what it means when something follows a normal distribution is that if we were to do a chart of their frequencies, it would roughly follow this shape. It's often referred to as bell-shaped. A normal distribution always has these characteristics. The mean is always in the middle, and it's always the most common value. So in other words, the mean equals the median, which equals the mode for a normal distribution. And then as you move away from the mean, the values become less and less likely. And the graph is symmetrical about the mean. So let's have a look at an example of a normal distribution. Let's imagine we measured the height of every male on campus. What we'd find is our graph might look something like this if we were to graph the frequencies. So we'd find the heights which occur most often will be at the mean. Let's say the mean is 170. So 170 is where we'd have the highest frequency. And then as we move away from 170, the frequencies decrease. You can see these bars are getting shorter this way, and similarly the bars are getting shorter this way. But it happens in a symmetrical pattern. So this bar is roughly similar height to this bar, this is roughly similar to this, and so on. And then when we get to the extremes, there's going to be very few people here. So very few people are above 200 centimeters, and there are very few people below 140 centimeters. Now let's consider what the standard deviation tells us in a normal distribution. Well, what we find is that for any normal distribution, 68% of our values lie within one standard deviation of the mean. Furthermore, 95% of values fall within 2 standard deviations of the mean, and roughly 99.5% of values fall within 3 standard deviations of the mean. So let's illustrate this in our height example. Let's imagine the mean is 170 centimeters, and a standard deviation is 10 centimeters. Then, as I said earlier, 68% of the people will lie within 1 standard deviation of the mean. So in this example, 68% of people will lie within 10 centimeters of the mean. So 68% of people will be between 160 and 180 centimeters. On the previous slide, we also said 95% of the people will be within 2 standard deviations of the mean. So therefore, in this case, 95% of the people will be between 150 centimeters and 190 centimeters. And we also said that 99.5% of the people will be within 3 standard deviations of the mean, so that will be between 140 centimeters and 200 centimeters. So we said that 68% of the people lie within 1 standard deviation of the mean. So writing that as a probability, it means that there's a probability of 0.68 that someone is within 1 standard deviation of the mean. And then we also said 95% of the people fall within 2 standard deviations of the mean, so therefore the probability of being within 2 standard deviations of the mean must be 0.95. And then finally, we know that the probability of being within 3 standard deviations of the mean is 0.995. So we know the probability of a particular value being within 1 or 2 or 3 standard deviations from the mean. In fact, we can find the probability of a value being within any number of standard deviations from the mean. We can just simply look it up in a table which is called the normal table. So what we have to do is calculate how many standard deviations above the mean our value is. The way we do that is we do value, take away the mean, divided by the standard deviation. So that gives us something called Z. So Z is the number of standard deviations above the mean. We then look up this value of Z in our table, and that will give us the probability. So, for example, if we wanted to find a value which is less than 1 standard deviation above the mean, we'd look up 1 in our table, and then we look at the corresponding probability, which is 0.3413. So therefore the probability a value is less than 1 standard deviation above the mean is 0.34. So if we doubled that, we'd get 0.68%, which is what I mentioned earlier. So that's the full normal table. So as I mentioned, we can use this to find the probabilities of values being within a certain number of standard deviations of the mean. Let's have a look at some examples. So, the heights of males on campus are normally distributed with a mean of 170 and a standard deviation of 10. And the question asks us to find the probability of these various situations. So first of all, let's find the probability that a male picked at random has a height between 170 and 180 centimeters. So this is the information we're given. The mean is 170 and the standard deviation is 10. And question A asks us to find the probability that someone is between 170 and 180 centimeters. So first of all, we need to find our value of Z, which is how many standard deviations above the mean 180 is. So we use our formula here. So we have 180, take away 170, divided by 10, which gives us 1. So we know that 180 is 1 standard deviation above the mean. Now we simply look up 1 in our tables, and we get 0.3413. So that's the probability that someone is between 170 and 180 centimeters. Part B asks for the probability between 170 and 190 centimeters. So again, we stick the values into our formula. This gives us a Z of 2. We look up 2 in our tables, and that gives us a probability of 0.4772. Part C asks for the probability between 170 and 185.7. So again, we put the values in our formula and we work out Z. This gives us 1.57. Now to look up a second decimal place, we need to go along the columns. So the rows, we look down to 1.5. The columns, we look to 0.07, and that gives us a Z value of 1.57. So we look for the corresponding probability, which is 0.4418. Part D asks us for the probability that the height is between 160 and 170. So again, we put the values into our formula, and we get Z is -1. Now our tables don't have negative numbers in, but because the graph is symmetrical, we can just look up 1. So when we look up Z is 1, we end up with a probability of 0.3413. Remember, we have a minus number because it is one standard deviation below the mean. Part E, probability that someone's height is between 146.2 and 170. So again, we need to work out how many standard deviations below the mean it is. Put it into our formula. So we get this, minus 2.38. We look up 2.38 in our tables, and we find that the probability is 0.4913. F asks for the probability of between 155 and 188. Now, because the mean is within this range, we have to consider this in two parts. We need to consider the probability of someone being between 155 and 170, and then we also need to consider the probability of someone being between 170 and 188. So looking at the first part, we stick the values into our formula. We get a Z value of minus 1.5. So that means 155 is 1.5 standard deviations below the mean. So we look at 1.5 in our tables, and it gives a probability of 0.4332. We now do the same thing for 188. Stick in the values, we get Z is 1.8, so therefore 188 is 1.8 standard deviations above the mean. Looking at 1.8 in our normal table, we get to 0.4641. We need to add both of these probabilities together. So we end up with 0.8973. Part G asks for the probability that someone's height is more than 170. Well, 170 is the mean. The mean is exactly halfway. So half the people are going to be above the mean and half the people are going to be below the mean. So the probability of being above the mean is just 0.5. Part H, the probability that someone is greater than 195. Let's consider this on the graph. We want the probability of the greater than 195, so this small region here. Now, the Z value corresponding to 195 is 2.5. But remember, when we look up 2.5 in our tables, it gives us the probability to the middle, to there. So it gives us the yellow region, which is 0.4938. We want the orange region. Now we know that the red region from 170 upwards is 0.5. So clearly the orange region is just the red region, take away the yellow region, so it's 0.0062. So the probability that someone is taller than 195 centimeters is 0.0062. Part H, the probability that someone is shorter than 162.4. Again, it might help to show it on a picture. If the mean is there, 162.4 is going to be below the mean, so roughly about there. We can find the Z value, which is minus 0.76. So we look up 0.76 in our tables, and that gives us 0.2764. So therefore, that probability is 0.2764. Now the question is asking us for the orange probability. We know the area for half of it is 0.5, the probability is 0.5 for half of it, so the orange probability must be 0.5 take away the yellow probability. So 0.5 take away 0.2764 is 0.2236. So that is the probability that someone's height is less than 162.4 centimetres. Sometimes you might need to work backwards from a probability to give you the corresponding value of the variable. If you need to do this, you need to look inside the normal table for the probability, obtain the z value, and then find the value of your variable by rearranging the equation from earlier. So the value of your variable is going to be the mean plus your z value multiplied by the standard deviation. Let's look at an example. The IQs of a group of people are normally distributed with a mean of 110 and a standard deviation of 8. Between what IQ values do the middle 40% of people lie? Above what IQ are the highest 10%, and below what IQ are the lowest 30%? So we're told that the mean is 110 and the standard deviation is 8. And question A says, between what IQ values do the middle 40% of people lie? So let's have a look at this on the graph. So the mean is 110, so that goes in the middle. And we're interested in the middle 40%, so that's represented by a probability of 0.4. So we want to find the IQ value here and the IQ value here. So we need to look inside our tables for a probability. Now, remember the tables give us the probability to the mean. So we're actually interested in the probability to the mean, which is 0.2. So we need to look inside our tables for 0.2. So there probably won't be the exact value that we want, so we just look for the value closest to it. So we can see that the closest value inside the table to 0.2 is 0.1985. And we look for the z which corresponds to that, which we can see is 0.52. We can now use our formula to find our x value, our IQ value. So putting the values into the formula, we end up with 110 plus 4.2, so it gives us 114.2. So we know that this value here is 114.2. In this question, we also need to find this value here. It's symmetrical, so that's easy to find. Basically, we're finding it when its z is minus 0.52, so we're finding the value 0.52 standard deviations below the mean. So we just do that calculation with a minus. So we take away 4.2 this time, so we end up with 105.8. So therefore, we know that 40% of the IQs are between 114.2 and 105.8. Part B says, above what IQ are the highest 10%? So on our picture, we're interested in a probability here of 0.1. So we want to find this IQ here on the scale. Now the tables give you the probability to the mean. So if this probability is 0.1, we know this probability is 0.5 because it's half. So clearly the probability left, the one we're interested in, is 0.4. So we need to look inside our normal tables for 0.4. The value closest to 0.4 is 0.3997. The corresponding z value for that is 1.28. So the IQ we're interested in is 1.28 standard deviations above 110. So we just basically put it into this formula. And we end up with 110 plus 10.2, which is 120.2. So we know that the top 10% have IQs are higher than 120.2. Part C, below what IQ are the lowest 20%? From our picture, this is the probability we're given. We want to find the IQ value here. So we need to look up 0.3 inside our tables. Closest value to 0.3 is 0.2995. That corresponds to Z equals 0.84. We stick it into our formula. But because we're going below the mean, remember we need to take away our Z. In other words, we have a minus 0.84. So we end up with 103.3. So the lowest 20% have IQs below 103.3. So to recap, in today's session, we looked at the shape and characteristics of a normal distribution. Remember, the mean is always in the middle and it's always symmetrical, and as you move away from the mean, the probabilities or the frequencies get lower and lower. We can look up all of the probabilities in a normal table. The tables give the probability to the mean, or we can work backwards. If we're given a probability, we can look inside the table for that probability, obtain our Z values, and then that will give us the value of the variable we're interested in.